Welcome back to the acid-base unit, ladies and gentlemen. This is Mr. Dang here, and we are learning about dissociation today. You should already have learned about the properties of acid bases. You should have learned about strong acids and strong bases, and you should have learned about Arrhenius acid bases, Bronsted-Lowry acid bases. Now, if you haven't learned those, please go back and do the assignment that goes with it, so that you are caught up. And so today we'll talk about dissociation. Okay, dissociation is the split up of ions of compounds, acid, bases, or whatever it is in water. And so we've learned that strong acids. There's a quick review here: strong acids and bases. Strong acids and bases dissociate completely. And dissociation, what we know what that means. It means ionization. Another word for dissociation is called ionization. They split up into ions, positive ion and negative ions in a water solution. So weak bases and weak acids, they only partially. Okay, so keep that in mind. They only partially, and not all of them will dissociate. That's why they're weak. They don't produce as much ions, and therefore they are weak acids and weak bases. And so this paper here, dissociation, we're going to start out with water being H2O. Okay, water. When you have a cup of water, a beaker of water, a certain amount of water, the dissociation, what is happening in the water, we don't see it happening, but there's also a dissociation of water molecules. It's called self-dissociation of water, and it splits up into H plus OH minus. Very, very, very small amount. Okay, and that's the equation. And the reason is that it's not 100% stable. There's things that there are salts, for example, that we think is insoluble, but when you put it in water, there's a very, very, very small percent, a very, very small amount that does split up. And so in water, it splits up into H plus and OH. And again, this H plus, sometimes you see it as H3O. Okay, hydronium, H3O plus, it's equivalent to the H plus, because it bonds with another water molecule to form the H3O. So what are the molecular concentrations of H and OH in pure water at 25 degrees Celsius? So at 25 degrees Celsius, both the H and OH are the same. So it's 1 times 10 to the negative 7 molar. Okay? And what that means is the concentration of H and OH are equal. So the concentration of H plus, hydrogen, and OH are equal. That's why it can go back to water. It can go back to water, split up, go back to water, split up, go back to water at a constant rate. That's how you get a pH of 7, because they are balanced. And when we talk about pH, which I'll go over a little later, with pH, it depends on the amount of H plus or OH minus in the solution to give us the pH. Okay. So what is the ion product constant of Kw? So ion product is a product of H and OH together, so it's 1 times 10 to the negative 14. This is really the magical number here for acid-base concentration for pH. That number is really useful. Okay, so number 4 here says find the H plus solution, H plus concentration, and you see these brackets. These brackets that you see, they are what we call concentrations. And in the last unit, the solutions unit, concentrations, it's molar. It's moles over liters. Okay, this is the unit, however, capital M, how many molars they are. So if OH is this, so it's OH times H, the concentration of H, gives you 1 times 10 to the negative 14. So you basically take 1 times 10 to the negative 14 divided by 1 times 10 to the negative 13. And you get your H plus, the H plus. Okay. Show your work on a separate sheet of paper so that you have room to just write your answers on here. Okay, so H plus. So it's 1 times 10 to the negative 1, which is really equal to 0.1. So that is the concentration of the hydrogen concentration of this solution A. Alright? So take 1 times 10 to the negative 14, divide by OH, you get your H+. Go ahead and finish these. Show your work on a separate sheet of paper. Get the answers on here. Okay? The OH and the H should multiply together to get 1 times 10 to the negative 14. Number 5 is very similar. Now we have H+. Remember, H+, concentration of H+ and OH minus is equal to 1 times 10 to the negative 14. That is the dissociation constant of water. Okay? And so you have 3 that, so to get OH you divide both sides by the H+. Right? There you go, that cancels out. So now we just plug numbers in. We plug H+ into the H to get you your OH. Okay? It's going to be a very small number, ladies and gentlemen. It's going to be times 10 to the negative something. Okay? So, but just be aware that these small numbers on top, the H and the OH, they should add up to somewhat about 14. Sometimes it's 13, sometimes 14. But the numbers will work out to give you 1 times 10 to the negative 14 when you multiply them. Alright? So go ahead and complete number 5. Pause this video, complete that. Get it checked with your neighbor, get it checked with myself, get it checked with me, and then move on to number 6. Okay? Okay, number 6. Number 6 here. They gave you a solution containing that many grams of NaOH in that many milliliter solution. So the first step, grams and milliliter, we need to know what the concentration is of the NaOH. Okay? So, again, concentration goes back to the solution unit. Molarity is equal to mole over liters. So I have to change this 0.635 grams of NaOH. I need to change it to moles, so then get Na is 23, O is 16, H is 1, so that's 40 grams of NaOH. It's equal to 1 mole. So I get mole there. 0.635 divided by 40, and I get 0.00159 mole. Divided by the milliliter, change that to liters, is 0.236 liters by 0.236, and I get the molarity is 0.067 molar of NaOH. Okay. So what happens here is, since we put 0.067 molar, it splits up completely. So we're going to have 0.6067. It's a strong base. So it splits up completely. This is 0.067 molar as well. So this is it dissociate completely. So then we'll get that much, this many OHs. So that is your concentration of the OH. Alright. How do I find H then? Then it's going to be, again, H and OH, H plus hydroxide, now multiplied by hydroxide, is 1 times 10 to the negative 14. So the 0.067 times the O times the H, that's the HOH already, is equal to 1 times 10 to the negative 14. Okay? So take 1 times 10 to the negative 14, 1 EE negative 14 here, divided by 0.067. I'll get, so the H plus is 1.49 times 10 to the negative 13. Okay? So find the molarity. Find the molarity. Divide 1 times 10 to the negative 14, divide by the OH, then you'll get your H plus concentration. As this is, concentration is very, very, very small, to tell you that, yes, there's only a little bit of this, so the concentration of this is very, very diluted. Okay? So go ahead and finish number 6. I already finished number 6. Go ahead and finish number 7, number 8, and number 9. 8 and 9. Alright, you see there's answers at the bottom here. There you go, that answer goes there. So if you find your answers don't match down here, then there's that answer. Let me see, 0.0673 right there. That's the. There should have been a 3 there. I just rounded it. So then 0.0673 there, and then 1 times 10 to the negative 7, like I put earlier. So the numbers of your answers are down here. If you don't see it down here, you might have done something wrong, or the person who made this probably just did it wrong. So finish this, get it checked, and then move on.